Hello everyone. Today we are showing the implementation of the final project or final lab of stopwatch. So from previous labs, you should be familiar with the operation of stopwatch so far, since we have designed the data path and the control unit. So our stopwatch allows the user to measure elapsed time and lap times of competitive events. Our stopwatch measures time in increment of tenth of a second, unit second, and tenths of seconds. Control input comes from two buttons. We call them S1 and S2, according to a finite state machine that provided to you on the lab document. Lab TA, Nolan Egging, will give us an overview of this week's lab.
Thank you, Professor Sager. In the previous two labs, you have created the data path and control unit for the stopwatch using these two components as building blocks. The architecture for the stopwatch, shown in figure 3, is almost trivial. The Verilog file for the stopwatch contains two component instantiations of the data path and the control unit blocks.
Great. So now Nolan will go over the model sim and then followed by development board implementation.
Right, here we are in the RTL simulation for Lab 12. I'm in the bottom left corner in the transcript area. We're going to be running the do file that you were given for this laboratory. However, please note that there are a couple changes or additions you need to make to that do file in order for it to run properly. However, a majority of those changes you've already made in previous laboratories. So anyways, I'm going to run that do file. It's going to do a little magic for us. All right, so it does some magic here. It's going to get all set up. All right, and now let's run it for 1,000 time units. An important thing here, if you did this correctly, you'll notice multiple tenths here. However, if you don't notice any tenths there at all, that likely means that the time constant that you count up to in your data path has not been adjusted. There are two values we use there. There's 3, which is great for test benches, and then there's 50 million, which is used when we're actually using the board and we have an actual frequency input of 50 million. Here we have the time constant is 3, and you'll notice we'll start and reset, stop, stop to run, then we go to run, and after every tenth, we're going to increment. Perfect. Right around here, we're going to go from the run state to the lap run state. Awesome. And every time we have a tenth occur, we're going to have a lap increment. And that's what we see here. And we go back and forth between lap increment and lap run until eventually we're pressing S1 or S2, and we're going to go from lap run to lap stop, and then lap stop, then lap stop to lap run again, lap run to run to stop, stop, stop to reset, reset, and then stop for the rest of the period. You may have some slight differences in your waveform compared to here. However, the fundamental behavior of the stopwatch should be the same. All right, everybody, so here's Lab 12 uploaded to our board. It's accumulation of the past couple of labs. But anyways, here we have our display for the tenths, the ones, and the tens place of our timer. We have S2 of our timer, S1 of our timer, and then we have the master reset of our timer. So anyways, right now we're in the stop state. However, if I hit S2, we'll immediately enter the run state, and we'll see that our timer starts counting up, and we go from the tenths to the ones to the tens place. So let's wait to get a tens place on there. Perfect, right there. If I hit stop, it's going to stop at that number because we've returned back to our stop state. Or if I hit S1, it will reset everything, return us back to the stop state. Let's do a little bit more complicated one. I'm going to hit S2 to get it running. And then I'm gonna hit S1 to put it in lap run. So right about now, so we're stopped at 5 seconds, or we're not stopped at 5 seconds. The output is displaying 5 seconds. However, the counter for the timer is still counting up. And this would be useful if we were maybe timing splits for like a relay team. So if I hit S1 again, return back to run, you're gonna notice that we jumped up a whole bunch. We jumped up about 20 seconds. And that's because the timer was still counting up, even though we were displaying a fixed number. So let's return back to the stop state and let's reset that number. All right, so for this next one, we're gonna enter the lap stop state. So we're at the stop state, we're gonna hit S2, we're counting up, then we're gonna hit lap run, perfect, and then let's go lap stop real quick. And what this does is we're displaying a fixed number and the timer has stopped counting up. Meaning if I exit the lap stop state and go back to run, we're not gonna have a huge jump up in our numbers because the timer wasn't counting without displaying us anything. So let's return back to lap run. Let's hit S1 to return to run. And you see, we jumped up a little bit because we were in the lap run state for a while, but it wasn't a major jump as if we were still running the timer all that time. So let's hit S2, we're back to the stop state, and then let's hit S1, reset, everything's good.